Hello everyone, welcome to this session on linear search, one of the simplest searching technique in data structures. In this video, we will understand what linear search is, how it works, its algorithm, implementation, dry run, and complexity analysis. Searching is the process of finding a given value position in a list of values. So as you can see, here in this image, linear search is a sequential searching technique in which each element is compared with the element to be searched one by one until element is found or the list ends. So over here, if the element is found, it returns its index, and if element is not found, then it returns -1. So this is how it works. Now we will see its algorithm. So as you can see here, it is the function for the linear search. As I told you, if match is found, it returns the index of the element. So that is why the return type of the search function is the integer value. Then this is the name of the function, and the parameters that we have passed to the function are the uh, list of elements. Okay, then the total number of elements in the list, and the third parameter is the element to be searched. So within the function over here, as we are sequentially iterating all the elements in the array, we have to make use of looping construct. So we have used over here the for loop. So for I is equals to 0, I less than n, the total number of elements, I plus plus. So if the match is found, the element to be searched, if it is if it matches with the element in the array, then in that particular case it returns the index of that match. Okay, if no match is found, it will check, or it will check the next element in the array. So likewise, it loop will iterate until all the elements in the list, and even though there is no match found, then only control goes to this statement and it returns -1, which implies element is not present. So over here, if we see, if we have given the array which is containing these elements, and the element to be searched is 31. So see over here, when the value of I is 0, a of I is, or a of 0 is 12. So 12 is not equal to 31. Okay, so it will increment the value of I. Now the next element at the index 1 is 25. So 25 is getting compared with 31. There is no match. Again, index is incremented. Then 17 is compared with 31. No match. Index is incremented. Then 40 is getting compared with 31, no match. Now the index is incremented, 31 is equal to 31. So as match is found, it returns the index at, in this particular case, is 4, so it returns the 4. So this is how it works. Now moving to the advantages and disadvantages of the linear search. As we have seen, it is the very simple algorithm, easy to implement, and it works on unsorted as well as the sorted array, and there is no pre-processing required. But along with the advantages, there are certain disadvantages. It is slow for large data set, as it has to perform too many comparisons. So that is the disadvantage. Coming to the analysis part, over here, the best case scenario is what? The element to be searched is present at the first index itself. Then we need to do only one comparison. So obviously the time complexity will be big O of 1, some constant value. Worst case, as well as in worst case scenario is what? The element is not at all present, or if present, it is present at the end of the list. So in that particular case, the number of comparisons that algorithm has to do is dependent on the number of elements in the array. So the time complexity in that particular case is coming out to be big O of n, and on an average the time complexity is big O of n, and there is no extra requirement of the memory space. So that is why the space complexity is a constant one. To summarize, linear search is one of the fundamental searching algorithm. Although it is not the fastest method for large data sets, its simplicity and ability to work on unsorted data make it an important concept in the computer science. Thank you for watching.